So today we will finish most of the Lagrangian section, but it will take much more time. We will again go to the Lagrangian, but before that we will start equation of motion, a little bit of Newton's law, and then we will again go for Lagrangian of a system. Okay, because it is very important that you have to analyze the system in complete way. Okay, but let's go for last problem. Last homework problem was spring pendulum, isn't it? So this is your M and this is your K. This is in G direction. So this is your mass M, and you have to just write the Lagrangian in Cartesian coordinate system. And this is basically in XY plane, isn't it? Okay. This is in basically XY plane. चंचूर आप अपने वीडियो ऑफ करो, है ना? So there is some problem with you. Hello? Yes. Okay. So this is your, now this is confined to move in XY plane. Then what is your X and Y? This is X, Y, Z you can write. And Z is equal to 0 is what? Your constraint. Then how you will write equation of kinetic energy? This is moving in plane. So kinetic energy is equal to half m x dot square plus y dot square, isn't it? And what is potential energy here? Your potential energy have two part. One part is restoring potential in a spring. And what will be this part? This is, and what is energy is stored into a spring? That is half k into change in length, isn't it? You have to focus on change in length. So what will be length, present length? What will be present length? बताइए. Half k root under x square plus y square. This is your present length. And what is your original length? This is your original length. So you can write half k x square plus y square minus L naught. And this is restoring energy in a spring. And then you have also potential energy due to this particular gravity interaction of this mass to the gravity. And this value is equal to minus mgy. Yes. So what is your Lagrangian? Your Lagrangian is basically kinetic energy minus potential energy. And this value is half m x dot square plus y dot square minus half k x square plus y square root under minus L naught whole square plus mgy. Okay. Now
नेटवर्क में इश्यू हो रहा था इसलिए लेट हो गया, सॉरी सर.
Okay, कोई बात नहीं. So what will happen? This is your Lagrangian, and after then you have to convert this Lagrangian into polar coordinate. यही दिया था ना next last class में. So जब आप Lagrangian को convert कर रहे हो polar coordinate में, then you can obviously have to talk about theta. What is your angle theta? You will always take from vertical axis because you are just want to know how your this mass is changing with respect to this gravity. And obviously this position is what? R and theta. So obviously what is your x here? X की value क्या होगा? The x is equal to R sin theta, isn't it? Because you are taking theta from vertical. And what is your y? Y is equal to what? R cos theta. And then you can easily go for this Lagrangian. This Lagrangian is half m, and that is r dot square plus r square theta dot square minus half k, and this value is equal to r minus L naught whole square plus mg. And what is y? Is nothing but r cos theta. So this is your Lagrangian into for this spring pendulum. Unfortunately, there is not any cyclic coordinate, neither r is cyclic coordinate, neither theta is cyclic coordinate. So we have to write the equation of motion, both r as well as theta. So what will be equation of motion? That will be d upon dt del L upon del r dot minus del L upon del r must be equal to 0. Then you have to write this particular thing, m r double dot minus mr theta dot square, mr double dot minus mr theta dot square, and what will be this value? Plus k r minus L naught. And what is this value? This value is plus or minus. This value is minus mg cos theta. Okay, so this is your equation of motion for r. Yes, and similarly, you can write your equation of motion for theta also. So let us try to write equation of motion for theta. यहाँ तक क्लियर है ना? वेरी सिंपल. आप जरा ट्राई करोगे इक्वेशन ऑफ मोशन थीटा में लिखने के लिए. जस्ट आई एम गिविंग यू 30 सेकंड. फटाफट लिखो तो जरा, देखो कुछ गलती होती है क्या नहीं. Just try to write your equation of motion in theta. Just try to write it. I'm just giving you 30 seconds. So this is, you can just match it. D upon dt del L upon del theta dot minus del L upon del theta must be equal to 0. So what will be this value? This value is d upon dt, and this value is m r theta dot square, isn't it? यही होगा ना? Sorry, m r square theta dot minus del L upon del theta. So here is not any theta, here is theta. Cos theta is equal to minus sin theta. Minus minus plus sin theta. So this will be plus sin. So plus. So this will be mgr sin theta must be equal to 0. Now यहां पर कई बच्चे गलती करेंगे. आपने ये तो 100% किया होगा. mr square theta double dot, but r is also dynamical variable, isn't it? So you have to write this particular thing 2mr r dot theta dot. So you have to take the derivative of this r dot and this plus mg r sin theta must be equal to what? 0. Are you people getting this thing? समझ में आ रहा है कहां पर गलती हो सकती है? एंड
Yes, sir.
है ना? तो ये आपको ध्यान में रखना है. एंड यू कैन सरप्राइज दैट अगर मैं r की वैल्यू फिक्स कर दूं, इफ आई विल go for r is equal to L or L naught, then obviously you will exactly land at the simple pendulum. Sorry, this will be MGS. ठीक है ना? This value is equal to 0. यहां पर तो कोई इसका कोई मतलब ही नहीं रहेगा इस इक्वेशन का. You have this equation and you will exactly land at the simple pendulum. देखो पहुंच रहे हो क्या? r is equal to L कर दो, m L naught square theta double dot plus 2m. This value is 0 because r is equal to L naught, and you have mgl sin theta. That is exactly simple pendulum. So simple pendulum is the one of the very important system जिसको कि आपको हमेशा दिमाग में रखना पड़ेगा, because any problem can be transform itself into simple pendulum. ये हमेशा होगा और आप इसको बहुत इजीली देख सकते हो. एक और मैंने होमवर्क दिया था जो फर्स्ट क्लास में था, उसे भी जरा देख लें एक बार, है ना?
Yes, sir.
जरा बताओ तो लैग्रेंजियन क्या आया था? एनीबॉडी कैन टेल मी, कैन मी रिमाइंड द लैग्रेंजियन जिसका मैंने होमवर्क दिया था? क्या था बताइए? हाफ m r dot स्क्वायर 1 प्लस b स्क्वायर r स्क्वायर, ऐसा ही था ना? प्लस हाफ m r स्क्वायर थीटा डॉट स्क्वायर एंड माइनस mg b r स्क्वायर बाय 2. यही था?
Yes, sir.
Yes. So this was my Lagrangian, and we have to write the equation of motion. So how you will write equation of motion? D upon dt del L upon del r dot minus del L upon del R must be equal to 0. So you have to be very much conscious at this particular point. So del L upon del R की वैल्यू क्या हो जाएगी? So del L upon del R is equal to M R dot square B square R, इसे डिफरेंशिएट किया, प्लस M R थीटा डॉट स्क्वायर, इसे डिफरेंशिएट किया, माइनस mg br. यहां तक तो क्लियर है? यस. And when you will go for del L upon del R dot, then what you have? You have M R dot 1 plus B square R square. Now, when you are going to put all this thing into this equation, oh,